We have the word chemistry. Then how many letters do we have here on the word chemistry? So how many different 9-letter arrangements can be made using all 3 letters? Why is it all 3 letters? All the letters, not 3 letters. Sorry about that. How many different 9-letter arrangements can be made using all the letters, not all 3 letters? So we have 9 letters, right? So you can use this one, you can show us the spots if you want, but there's an easier way of doing this. You can actually use the factorial, so it's going to be 9 factorial. I hope it makes sense. But if you want to do it this way, you can do it. It will be 9 times 8 up until 1. Then when you multiply those things, they give you the answer. Then you write arrangements. So the solutions here for the first question is going to be 9 factorial, which is 36288 arrangements. Then number 2, they want us to determine the probability that the vowels E, I, Y are always together. So you ask yourself, you know that when you talk about vowels, we talk about A, E, O, and U. Then these are vowels. You ask yourself if Y is a vowel. Yes, we treat E, I, Y as one block. Now, what you must actually understand here is that we're going to treat Y as what? As a vowel. I'm not sure if you understand that. Let me just try to explain that. We'll treat Y as what? As a vowel. Why? Because Y is called a sometimes vowel. It acts as a vowel when there's no other vowel sound at the end of a word, like chemistry. So it acts as if it's a Y. I'm not sure if you understand that. So the Y makes the E sound. So it is the word we count Y as a vowel. That's the reason it is sometimes called a vowel. I hope it makes sense. Now we have these block here as what? So we're going to treat this block EIY as one block. So the reason we call Y a vowel is that it is Y is called a sometimes vowel. You can ask your teacher about that, your English teacher. It acts as a vowel when there's no other vowel sound. I hope it makes sense. Like my, cry, gym, why. You see, at the end of a word, like in chemistry, happy, baby, there's no what, there's no there's that vowel sound. That's why is called sometimes vowel. I hope it makes sense. Okay, then what we actually can do right now, we're going to take this block E and Y to be in one block. Why? Because they said are always together. So we put them here, then we are left with what? C, M, no, it's not M, it's H, right, for chemistry. The 3 are in one block, so we are left with CH, M, S, T, and the R. The R, we took the 3 to be in one block because they say they are always together. So meaning that these 2 here are already out. Why? Because the 3 vowels are in one block. So we have how many? We have 7 spots right now, or we have 7 spaces where our alphabets are actually placed. I hope it makes sense. Then what do we do now? What we're going to do right now is, now since we have these 3 in one block, we will actually write them as what? As 3 factorial because we have 3 spots. I hope it makes sense. Then apart from these two, from these 3, we have 6. Then altogether there are 7 spaces. But if we separate the 3 block from the other blocks, we're going to have what? 6. Therefore, altogether we have 7 factorial multiplied by the 3 factorial, the block having 3 vowels. Then that's going to be 5040. That's the answer for 7 factorial. Then for 3 factorial, we're going to have what? We're going to have 6 over, we're going to have 6 right here. Let me just confirm it with my calculator. So here, these ones, we have 6 of them. If we do what? We separate them from the first block. So we're going to have our answer as 30240 over the sample space. The sample space is what? The different 9-letter arrangements in question 1, which is 9 factorial. Therefore, we're going to divide 30240 by the answer that we got in question 1. I hope that makes sense. The 9 factorial, which is 362880. I hope that makes sense, guys. So the probability will be 30240 over what? Over the sample space, which is the 362880. So we're going to divide this answer of ours. The probability is going to be the favorable arrangements over the sample space, which is the 9 factorial. 362,880. Then our answer is going to be 1 over 12. So this is the probability. I hope it makes sense. Very, very important. So try to do this one on your own. Then after that, I'll send you guys corrections. I think maybe on the next video. So consider the word signs. Then they ask us about how many different arrangements can be made. Using all the letters. So this is for 2 marks. And number 2, they want you to determine what? The probability that both C's are next to each other. So try to do this one, even though it's a bit tricky, but try it.